corpuscle is including the glomerulus and the glomerular capsule, which you can see in green. So each one of those is a renal corpuscle. Okay, so looking at a cross-section through the renal corpuscle, the red part that you see is a fenestrated capillary called the glomerulus. And entering the glomerulus is the afferent arteriole, leaving is the efferent arteriole, like E for exit. And the afferent arteriole has a variable diameter. So we can increase filtration if we open this up and let more fluid come in. So that's what this is. This has adjustable diameter right here. So this green layer right here is the visceral layer of the Bowman's capsule or the glomerular capsule. And the cells that make that up are the podocyte cells. And those create a filtration slit. The outer layer that you see right here, that is the parietal layer of the Bowman's capsule. Visceral layers here, parietal layers here. This is the tubular pole right here. And the tubular pole is where the proximal convoluted tubule is going to be. A prominent feature of the proximal convoluted tubule is the presence of these microvilli, which you can see in blue right here. So that makes the lumen look kind of fuzzy looking. About 65% of the absorption of nutrients or the reabsorption of what gets filtered is going to be in the proximal convoluted tubule. So all of these are examples of proximal convoluted tubule. And the way that I know is because of the presence of the microvilli. Now this here, this is a distal convoluted tubule. And the distal convoluted tubule is going to connect with the collecting duct that you see right here. The reason I know that this is a distal convoluted tubule is these cells that are close together, that are very kind of got a tall-like appearance, not well shown on this model. These cells are monitoring the filtrate. These are the macula densa cells monitoring the filtrate. And then this, lastly, is a collecting duct. And this is what here we determine whether or not we're going to produce concentrated or dilute urine. So antidiuretic hormone is actually targeted here. The antidiuretic hormone is actually targeted, the collecting duct right here. Now looking at this model right here, just to get more of a view right here, and we can kind of go back and forth here a little bit. Okay, so here, these are the cortical radiate arteries that you can see right here. And branching from the cortical radiate arteries is the afferent arteriole. All of these are afferent arterioles, also shown right here. That's also an afferent arteriole. Now on the other end, leaving the glomerular capsule, leaving the renal corpuscle, is the efferent arteriole. That is shown right here on all of these. The efferent arteriole will give rise to the peritubular capillaries. You can see peritubular capillaries right here, this net-looking stuff right here. And this is the efferent arteriole giving rise to those. And this part down here that is surrounding the nephron loop down here and surrounding part of the collecting duct you can see here. And you'll notice you've got a part that goes straight. So this is also a type of peritubular capillary. But because it goes straight, we call this the vasa recta. It means like straight vessel, is what it means. But it is also a type of peritubular capillary. So now looking at the features here. So here is the renal corpuscle, which we can also see here. The renal corpuscle includes the glomerulus and the glomerular capsule or Bowman's capsule. Attached to that on the tubular pole is the proximal convoluted tubule, shown kind of in a tan color here. I guess it's a tan color. Is it tan or peach? I don't know. Brown looking thing right here. Okay, so you can see that right here. And then you can see that it goes down here. And then this part of it right here, this is the descending nephron loop right here. And then this is the ascending nephron loop right here. Or you could say ascending limb of the nephron loop. So descending limb right here, ascending limb of the nephron loop. You can see this part is skinny on the nephron loop here. That's the skinny part right here. So you've got a thick side and a thick part and a thin part. And there's the thin part. You could see it right there. Okay, so here is the ascending loop right here. And then the ascending loop is going to go into the distal convoluted tubule right here. And multiple distal convoluted tubules empty into a single collecting duct. And that's what's shown right here as the collecting duct. Now, some other features here. And she's got her goggles. She's okay, I think.
I'm ready, guys.
She's cool, I think.
So it goes into the collecting duct?
Yeah, it goes into the collecting duct.
And that goes to just to...
That actually goes into the papillary duct, which is going to drip from the renal papilla, which goes into the minor calyx. That goes into the major calyx, goes into the renal pelvis, goes into the ureter, goes to the urinary bladder.
Into the toilet.
Actually, out the urethra, out the external urethral orifice, through the air in a stream, and then into the...
through the air. Forgot about the air. Yeah.
Well, this is getting technical on that. Okay. So where was I on this? Okay, this part is the cortex, by the way, and that part is the medulla. And we're showing a couple of different kinds of nephrons. So 85% are these cortical nephrons. So this whole thing right here, that type is a cortical nephron. This type right here, you'll notice that the nephron loop goes deep into the medulla. That is a juxtaglomerular nephron. And this is about 15% of the nephrons, and they're going to be important for making concentrated urine. And so we'll talk a little bit more about that in lecture, but these are going to be involved in making the concentrated urine. So we can concentrate it about 4 times. And so right here, once we establish the concentration gradient, the collecting duct uses that concentration gradient. So if we target it with antidiuretic hormone, more water is going to go out, so we'll lose less water, and then we end up concentrating it, and we have less urinary output. So, okay, so I guess we should say, like I said, arcuate artery and vein, afferent arterial, efferent arterial, cortical radiate artery and vein right here, paratubular capillaries including the vasa recta right here. And you'll notice that the paratubular capillaries are a branch of the efferent arteriole, as are the vasa recta as well. So I think we're good on those.